Good morning or afternoon or evening, ladies and gents. I know you cannot see me, but I hope you can hear me. Today, we are going to be looking at two videos on a new topic that we're going to be covering called similarity. Let me get my similarity is our topic. Now, I'm going to start by giving you some examples of similar shapes. Similar shapes you want to think about like models, not like pretty people, but like model cars. Right. The reason is when we think about model cars do a great job of resembling similarity because similar shapes, like congruency, they're not the same size, but notice they are the same shape. But they're the same shape. Notice here, these two are similar to one another, right? They're the same shape, they're both rectangles. And notice, even as I change this to be a smaller one, it still retains the same shape. Thus, they remain similar to one another. The way we write out similarity is we use this symbol here, and I'm going to actually put it between them. The way we show similarity again is it's kind of just like the top part, if you remember, of congruency was this. Congruency was this, right? It's just the top part is similarity. So continuing this, again, similarity has to do with the two shapes being the same, but just different sizes. Now, I'm going to show you an example of not similar shapes to give you some help there. Uh, So we have one shape here. In fact, I'm going to shrink this a little bit. We have one shape here. Notice these are similar. To make these not similar, what I'm going to do is do this. Notice these shapes are no longer the same. I've changed the relationship between these. Notice this one right here. These are clearly not the same size and they're not the same shape. You can see by how, you can look at it and tell, well, these aren't the same. And what we're going to do is we're going to figure out how do we determine, what similarity means and how we can use it. But the big thing of what we want to be looking for, and I'll bring this up right here, is how do we show similar figures? Notice again, for similar figures, just like congruency, let me turn on my drawing. When we're looking at congruency, notice again we have our symbol here that shows congruency. And we have two similar triangles, right? This triangle here, this triangle here. Notice they are the same shape, just different sizes. The way we look at congruent figures is first we look at corresponding sides, just like we did for congruency. Notice A, B, A, B, D, E. I've lined those two up here. Notice they're not the same, that's okay, but I put smaller and larger. Notice that simplifies to be 2 over 3. Or if you plug it into your calculator, if you do 10 divided by 15, you get 0.66. If we look at our next set, our next set would be BC and DE, which we have right here. Notice when we set up the relationship between these, we get 8 over 12, which we type into our calculator as 0.66. Lastly, if we look at, let's try AC first and last with DE first and last, we get 6 over 9, which if we plug that into our calculator, we get 0.66. For figures to be congruent, or sorry, for figures to be similar, their corresponding sides are not the same, they are proportional. We need the ratio of small triangle to large triangle for all of the sides to be the same. This type of proportionality shows us these figures are the same. Another key element we want to look at here is about the angles. In similar figures, the angles are congruent. So here we can say angle A is the same as angle D, right? First with first. Angle B is the same as angle E, second with second. And angle C is the same as angle F, the third with the third. The angles are the same or congruent, and the sides is where things get a little bit different. The sides are proportional, and this is what it means by proportional. We take the comparison of the corresponding sides, and if we set up all three of them, they should be the same. Um, so make sure you get this down. This is the basic definition of what similar figures are. So as we continue to look through this, in our next video, this is just going over the definitions. In the next video, we're going to talk about how we utilize similar figures and how do we determine if figures are similar to one another. The big takeaway is, remember, same shape, different size, right? The same shape tells us about is given by the angles. Not the same size comes from our sides being proportional to one another. So that is our key factor, what we're looking at for similar shapes. Notice again, example of similarity, same shape, different size, versus our non-example. Notice these are not the same shape and they're not the same size, so therefore not they are not similar. Well, guys, I hope you found this video helpful. Um, in the next video, what we're going to be looking at is some of the applications of similarity. So we'll catch up with you shortly.